All right, so there are lots of scenarios where we would want to incorporate a categorical variable into our regression data set. And to incorporate those categorical variables, we have to use what is known as an indicator variable. So if you're just plugging in words like yes or no, or weekday, weekend into your model can't handle that, right? Words don't work with math. So what we do is we code it as what's known as an indicator variable, which has zeros and ones. So zeros correspond to one category and ones correspond to another category. Okay, by using these indicator variables, by using these 0, 1 variables, it allows us to actually do math, right? We can naturally add and subtract and multiply and divide zeros and ones. So in our example, what we'll be doing is using an indicator for spring. So in this case, if it's summer or fall, we're going to use a 0. We also sometimes say that 0 if not spring. And if it is spring, if the observation does come from the spring, we're going to use the indicator 1. All right, so to evaluate this in R, it's actually very easy. You're just going to use the same types of formulas, right? We're predicting volume from spring. And then we're going to plug that into our linear model command, right? We can print this out and we've got the same type of things, right? We have an intercept still and we have a slope. Now, because we're working with zeros and ones, the meaning of these intercepts and slopes changes just a little bit. So the estimated intercept is the value of the response variable for the first category. So for not spring, for summer or fall, we expect 380.757 rail trail users. All right, this 0 category, the category coded as 0, is sometimes called the baseline. All right, now the estimated slope is a little bit different. The estimated slope is the average change in the response variable between the two categories. So we had a slope of about -9, and that means when it's spring, we expect about 9 fewer rail trail users than we would if it was summer or fall. All right, we can actually do the math. We can do 380.757 minus 9.096, and that means that we would expect 371.661 rail trail users during the spring. Okay, now maybe you've noticed, maybe you've given this some thought, but we've really only talked about how to include categorical variables with 2 levels so far, right? We have spring and not spring. And obviously there's an example that immediately comes to mind. It might be much easier to code, or we might want to code a linear regression using 3 variables. In this case, spring, summer, or fall. Remember that we don't have data from winter, so we can kind of ignore that for now, right? So the way that I've written this, mathematically speaking, is volume based off of season, where season is spring, summer, or fall, which is more detailed than just spring or not spring. I want you, before you start the next video, take a minute and think to yourself, what sort of a logical thing that you might do to get a categorical variable with 3 levels incorporated into your linear regression.